Hi class, let's continue to discuss overloading operators, this time the extraction and insertion operators. So they are both binary operators because they have operands in both ends. So if you think about the unary, it's a negative in front of the number. So there's only the money. So there was only one operand that it operate on. Is only one money value. When we talk about binary operators earlier, we have two values that we are playing with. So it's amount 1 plus amount 2. So amount 1 and amount 2 are the two operands that plus will be operating on. But this time the binary operators are a little bit different because the one that comes before and the one comes after are actually different types. The type that is in front is either for this particular operators, the one in front is either input or output streams, and the one after are some kind of data type. It could be integer, or it could be money, it could be just text or characters, right? So to overload these two operators, the syntax is exactly the same. We need the friend keyword, we need the return type, which we are actually returning the input stream by reference. In this case, we use the operator keyword, and then we use the symbol that we've been using. That's why it's called overloading. It's reusing basically something that we've been using in the standard library in this case. And then we have the operand that's in the left hand side, and as the first parameter. That's why it's the input string. And then amount, the money object will be in the right hand side when you call the function, right? So it's like cin arrow and then amount. Same for output stream, this insertion operator, that's what it's called. One thing I want to get your attention is that here, because we are going to change the value of amount, so we are passing it by reference, and there's no constant keyword in front of it. But when we are outputting it, we are not going to change anything in the money object amount, and so we can put a const there to make sure that we don't accidentally change anything. Just want to mention the comments are beautiful that the textbook has, so take some time to look at it. To me, it's a little bit too long, so I actually change it a little bit. But it's important to implement an ADT in your project that's in your lab. I expect that you would have comments for everything, or of course everything, but it's especially important when someone else is going to use your class, right? So to demo how to overload this extraction and insertion operators, we are going to look at some code. So like we talked about before, the friend function will be put in the class definition and preceded by the keyword friend. And then when you implement it, you don't need the friend keyword, and you don't need the class : I want to I want to basically just go through the whole code with you so that you understand how we parse P-A-R-S-E the input, because you are going to have to do this in your lab. And also I feel like it's a good opportunity to reveal how to basically get input from the input stream. So let me put this here. Well, I guess like this. So let's say so what this function actually expects, first of all, right? We actually can put in negative $15, for example. That's one of the valid input. And then another one is something like 5.04. And so that's what we expect. And so if it doesn't conform to this syntax, we would say, hey, sorry, there's an error. So how does the code work? So let's say we are typing in a valid number. First line of code, we are getting one character. So if the first character is a negative, it will set negative to true. Otherwise, it will set it to false. And then when we get and then if it's a negative, then we expect the next one will be a $. So we get one more character. So we will expect after this, no matter if we go through this, if cause or it goes through the else body, we would always have the $sign in the one character then. So next, we are going to get the dollar amount. We expect, here will be 15. And then we would expect a decimal point, a dot. And then we actually would get two digits, digit number 1 and digit number 2. That's how we are processing it. In your textbook, it actually talked about why it does it that way. Because if you just process, you give it a 0, 4, for example, it will come up with 4. Anyways, I mean, for me, this is just to show, this is one of the ways to implement it. This is not the only way. So, like I said, if the one character is not a $sign, or if the decimal point is not a decimal point, or if the digits are not digits, then it will say error. Nice, right? But if it is like everything goes like we want to, then it will calculate the cents part. So we know the dollars is 15, let's say, and then it will go and calculate the cents part. So how it do it is, because we are accepting the digits like a character. So look at the declaration. It's digit 1 and digit 2 are processed as a character and not a number. So remember, the value of 0, for example, as a character actually is not evaluated to 0. And that's why we need a function called digit to integer. It will accept a character, and then it will return the integer value. And so maybe I can show you this. So what are the value of 0 as a character? Actually, it's 48. Was the value of 4 as a integer, as a character? What is the integer representation? Is actually 52. So how to get the value of 4 if it's represented as an integer, as a character? So we would use 52 minus 48, and it becomes 4. That's actually how we are going to do it. And that's how it's implemented. So we would typecast the character 0, and then we will typecast the character C, and then minus them. And that's how we get to the value as a return of an integer. So here, maybe 04 is easier to explain. So how about 14? So so 1 will come in as digit 1. It will come to this function. It's set digit to integer, and then it's a character of 1. So it's typecast to value 49. If we want to look at it again, 49, it's character 1 will be evaluated to integer 49. And then and then here we are still here. This is 48, so it will return an integer of 1, and so cents will equals to 1 times 10 plus 4, which we will test this function, make sure this works, and then plus 4. So then the cents will be 14. And amount of cents will be the dollars that we got, like 15 times 100 plus the cents that we got, 14. So it will the money will be represented by 1,514 cents. If there's a negative and if it's negative, we would then use the unary operator that we overloaded earlier, and then and then set the all cents to that value, and then we return the input stream back outside of the function. So this is how we overloaded this extraction operator. Like I said, you would have to do something similar to for the rational numbers. I think I would do a video on that so that I can give you a little bit more tips, but now you see how this is implemented in this case of money. So just to mention briefly that we do the same for the output stream. This is the insertion operator, that's what it's called. I'm not going to go into details, but the basically idea is exactly the same. So to recap, we demoed how to overload the extraction operator more than the insertion operator actually, and then we discussed how to get the integer value from a character. Next, we are going to talk about, I guess that's it for the class material for this module. We are going to talk about the rational number class for your lab.